Rightio, welcome to the first video on the first spectroscopy technique, and this one is infrared spectroscopy, or IR for short. So the purpose of this type of spectroscopy is to identify the presence or the absence of any functional groups. How it works: so we have a wee sample and we want to know what we've made, or we want to know what sample we have taken from the scene of the crime. Probably not, but let's give that a go. Okay, so what we do is we take our sample and we put it in the big machine and we fire some infrared radiation at the sample in the machine. Now that sample absorbs some of the infrared radiation and transmits the rest. So we then have a detector, and the detector detects which wavelengths of infrared radiation have been absorbed and transmitted. And what we get from the detector is an output that looks like this. So it's kind of like a little graph. Okay, so what does this graph show us? So let's look at the axes first. So on the vertical axis, we've got the percent transmittance. So at each wavelength, how much is absorbed and how much is transmitted. Note that the zero is at the top, so we read the peaks from top to bottom. And along the horizontal axis, we have the wave number. So it's kind of like the wavelength of the radiation. Just note along the bottom here, it is a numerical axis, but it's not evenly spaced, so just be aware of that. So if you see there's a gap of 500, 500, 500, and then we have 1,000 and 1,000, and that's pretty common. There is no numerical axis up the side, so it is just an estimation. So this isn't quantifiable, it's just qualitative. We can see what's there, not how much of it. So each of these things here is called a peak. Okay, and we have to be able to identify our peaks by two things. So first of all would be by where they are found on the spectra. So for example, this peak here is found at about 1750, and I say about because this is never perfect. So we can use the scale along the bottom to identify the peak. This one here, as you'll notice, is a very broad peak, and that is an acceptable way to describe the peak. And on your resource sheet, which you will get, it has probably got a range. So you can use a range if the tip is not strong enough or not sharp enough to be able to identify one particular point. Okay, so we've got broad. If they're pointy, we refer to them as sharp. If they are very long, like this one here, we call that a strong peak. This one here, these two would both be kind of medium peaks. And this one here would be a very small, just a small or a weak peak. So that's mainly it. We've got some peaks. We can describe them by what they look like and by where the numbers are. One more thing is that this region down this end of the spectra is called the fingerprint region. It's got a lot of detailed information and it's really hard to read. We tend to ignore this region mostly. It is called the fingerprint because it is really unique for each molecule, but it's also really hard to read, so we tend to stay away from it. Couple more things before I stop this introductory video. Down here, I just want to show you two other types of peaks. This one here is called a doublet peak. As you can see, it's got two peaks in the single peak. And here we have this main peak, and we call this a shoulder peak. Okay, so it's a little one off the side of the main one. Just other terms that you might come across. Okay, that's the end of the introductory video on infrared spectroscopy.